So hi and welcome everybody. Welcome back to the course titled Computer Networks for Beginner. In this course, we are gonna be talking about computer networks principles, the basic concept of computer networks, what they do. So basically, computer networks are emerging a trend in our current era, the digital life, the digital era we are living in. You can find them anywhere, at homes, offices, schools, universities, wherever you go. You cannot find a place you go to on your daily basis, you don't find or encounter or face networks. Without networks, you will not be able to have internet. And internet is one of the core basic needs that we all are dependent on in our daily life. That what are the bills that you receive each month to your home? You receive the food bill, the electricity bill, the water bill, the gas bill, and the fifth one is the internet bill. So imagine your life without an internet. So we are so dependent on the internet, and the core backbone technology that's building the internet and making the internet exist and provide you with all the services and all the applications is the networking, the computer network concept. So from that perspective, computer network is very important. Without computer network, you wouldn't have internet. You wouldn't have been able to transfer applications, services, use them over the internet, and use them for your work, for your communication, for talking with people over a very long distance, and playing over the internet, gaming, communicating, working, learning. All these activities are fully dependent on the existence of a computer network that can enable all these services and applications for you. So that means that learning the basic stuff of computer network and how to set up a simple computer network and be aware of the surrounding networks around you is very important thing, beside the other important subjects that you learn in your daily life. So this is why computer network is important. And as I said, it's a basic fundamental need in your daily life. It's like electricity and water and food. You cannot imagine your life without internet. If you cannot live without internet, then you cannot live without the computer network concept. So in this picture, as you can see here, this just resembles a simple, brief, basic overview of the shape of a computer network globally. So basically, a computer network consists of end devices communicating over a very big, large network to servers and data centers and data sources, where the end devices are composed of laptops, tablets, phones, wearable devices, basically any device that you can connect to the internet. And then these devices are connected through either wireless access point inside your building or inside your home. And this access point is connected via fiber cable or sometimes copper or coaxial or any type of medium that connects you through the public switching telephony network that provides you with the ADSL or VDSL. And this connects with some switches and then routers, regional routers, and then big international routers, which represents the gateway between your internet service provider and the internet, until you reach to your web server or data server or file server, whatever, and request the data, and the data comes back to you. So in this figure, we can see that we have end devices. These are the end devices. We have links in green, which represent the regional internet service provider. We have links colored in blue, which represent the backbone internet service provider. And then these are connected with another international service provider via bridges. And those are also connected with other links, and then until they reach to the server, or like YouTube server or Google server or whatever, until you in order to get your application or service. So this is just basic overview, and there are dozens of networks, like thousands of ISPs, all of them interconnected with each other in a meaningful way, seamless way, so that they can provide you with the best possible service. So this is in a nutshell what computer network is. And here, if you are asking yourself, what are the things that I'm going to be learning in this course, then you can summarize them in the following points. First, you will be able to recognize the computer network implementation on various levels and explain how they work with each other. Then after that, understand the network concept and the need for networks. Set up a basic LAN, basic WAN, set up Wi-Fi connection, and how to connect them with each other without any mistakes or error, and also to configure whether this device is connected to the internet or not, how to check it, how to trace your packets. For example, if you are asking to access Google, how does the packet generated from your PC goes from one link to another, from one router to another, until it reaches the location of YouTube servers or Google servers and return back to you? How much time does it take? And how long, how fast the response will be? Do you know which path it took? Why didn't take this path but prefer to take this path? Because this path is closer, is faster, or it provides you with a better quality of service. All of these details are going to be explained in this course. Recognize networking devices and implement them in a computer network. Differentiate between network topologies and differentiate between network architectures. Tell the difference between communication modes. Explain the basics of the OSI layer. This is one of the most important concepts that you have to be familiar with. The OSI layer, the 7 layers, starting from the application, presentation, session, transport, data link or MAC layer, and then the physical. So you computer guys, computer engineers usually are specialized at the application, and sometimes they go up to the networking. But the electrical engineers are usually specialized at the physical and MAC. So to get full comprehensive understanding of all these layers, I know that you might not need to be specialized in the physical layer. People spend 10 years until they understand it, and they do PhD on the physical layer just to understand it. In this course, we are gonna just give you a glimpse, an overview of what this physical layer is. What does it do? For example, what's modulation? Anybody here from the computer engineers know modulation? What's modulation at the physical layer? What's coding? What's encoding? And how many types of coding we have? So these are basic concepts. I know that it's out of your scope sometimes because you are totally immersed and focused on the application layer, building apps, mobile apps, web apps, machine learning, AI, whatever. But at the end of the day, to be really very good engineer, you need to have some basic stuff, some basic knowledge about also the other layers which are out of your scope sometimes, the physical and the MAC and what they do. And it's very critical and important to understand at least the meaning of coding and meaning of modulation. Modulation, what's modulation? Why do we need it? How to do it? How to represent data and compress it, how to protect it, and so on and so forth. So these are the main things that you are gonna be learning. And the lessons are structured in such a way that the lessons that come after are dependent on the previous lessons. So if you missed any lesson, you will find some difficulty understanding the consecutive coming lessons. So make sure that you don't miss anything and you understand all of them. And if you have any questions, you reach out to me and come and ask. So let's begin by defining what a computer network is. So a computer network, if someone asks you to define it, it's basically a set of nodes connected by communication links. What are these nodes? When we say nodes, what are these? Give me an example of these nodes. Any device that's capable of connecting to the internet, this is a node. How do you say this device is capable of connecting and this device is not capable of connecting? If the device has communication capability, then this device can be connected to the internet. Give me examples of communication capabilities existing inside your mobile phone. Bluetooth, Wi-Fi, 3G, 4G, and in the future 5G. So these are communication gateways. With these technologies, you can access the internet. With these technologies, you can communicate. Imagine I give you a phone, very smart phone, very amazing phone, beautiful phone, but let's tell you, there is no Wi-Fi, no 3G, no 4G. So what's this phone now? It means when I get these communication gateway from your phone, it means now you cannot communicate. Your phone becomes just a toy, a game. You understand me? So the value of your device is in making you capable of talking and communicating and sending and receiving data, isn't it? This is the value. And imagine having a device without internet. What's the value of the device? So the internet is like the oil, the fuel of the engine of the car. A car without diesel, what's the use of it? Without petrol, can you use it? Very beautiful car, very smart car, very amazing car, but without petrol in it, it cannot drive. Just like the car, the phone works in the same principle. Without the internet, the petrol of the phone, it doesn't work, it doesn't function, it doesn't let you communicate, it doesn't allow you to reach the internet, which we use it frequently to work with each other, to connect with each other, communicate and learn and exchange and share. Just to try to turn off the internet from your phone and see what's the value of your phone. So the core value is in giving it connections. So two important things. Nodes, computer network, is a set of nodes connected by communication links. What are the communication links? Give me examples of communication links. Cables, copper cable, fiber cable, ADSL cables, or sometimes it's the medium, the air, wirelessly. When you connect to your Wi-Fi or 3G, your mobile phone, what's the medium? You are not you don't have anything to connect with the internet. You are connecting it. You are connected with the internet wirelessly. Wireless. So imagine you are using a medium that you don't see. Something is generated from your phone, reaching out to the access point, responding back, carrying your information and carrying back your response, and you don't see it in your eye. It's that when you think deep about it, it's like magic. If you go deep into the physical layer and understand how this happens, you will be shocked. Like, we are surrounded by signals, always carrying data around us. Things that are happening 24 hours around us, but we don't see anything of them. So this is the magic of communication. So again, simplifying this definition by explaining node and communication link. In general, node is a device that's capable of sending and receiving data generated by other nodes. Communication link can be a wired link or wireless link. Wireless link is the preferred medium of communication. Everybody, why wireless is much better than wired? Why? If I ask you this simple question, why wireless is much better than wired? What comes to your mind? Freedom of movement. Mobile, I can be connected with the internet from wherever I am. Yes? But if you have wire, if you just dependent on wire, if there is no wire, I will not have any access to the internet, isn't it? Which is bad, which is really bad, not very good. So this is another example of, this is like example of computer network, where you have in this side the printers, you have PCs connected with a switch. You will learn also exactly the meaning of a switch. Why do we need a switch? And then this switch is like for a local area network connected with a router, wireless router. And this wireless router is connected with another router that's not wireless. And this router, which is bigger than the previous router, is connected with the cloud. The cloud here is the internet. And this is connected with a modem. And the routers might also be connected with a cell tower for mobile phones, which is connecting smartphones with it. And here you have in the cloud, you have also all types of servers, web servers, file servers, media servers, whatever, which provide you with a service. So the internet has three things. The internet, to have a network, to have an internet, you have three things. You have nodes, devices capable of connecting and communicating and receiving. You have links, communication technologies, and you have services. Yes, services, web, email, voice over IP, gaming, all these are services that make the internet useful. Without, for example, let's say you have internet, but you don't have any service. What's the point? Useless. So all of them are integrated with each other, and no one can work independently of the other. All of them are interconnected and work together in order to form an internet, a network. Another use case, let's assume that all of a sudden there is an earthquake and the internet gets cut. There is no communication. So as an engineer, can you quickly build a communication network for people to rescue them, to connect with them? If there is an earthquake, the base stations, everything will collapse, yes? So can you quickly to rescue people and take care of them and build a network, wireless or wired? So this is a question. For example, few students they are working with me in this semester, they are trying to build a rapid deployable network. If I lose my internet connection for any reason, can I build a wireless network quickly? How to build it? So this is a question that if you are interested, you can search about it and learn more, but you need both the communication knowledge and the networking knowledge in order to be able to build such a system. So a good example of links and nodes, the devices which are the source or the destination in the communication link, are called end devices. Another name for these nodes, if the nodes are at the end of the network, let's say they are here, they are located in this place, we call them end devices because they are placed or at the end of the network. If the devices are in between like switches and routers, we call them intermediate devices. So the devices which forward the data from one side to another side are called intermediary devices. Intermediary devices, give me examples of intermediary devices. Switches, routers, hubs, bridges, firewalls, these are all intermediary devices. Intermediary in between, not at the end. Now let's talk about the basic characteristics of any computer network. What are the things that this network should possess so that we can call it's a good computer network? First, it should be fault tolerance. It should be able to correct errors and reconfigure itself. Scalability is another important metric. It can be scalable easily. And the quality of service, and fourth, security. Security, a network that's not secure, it's not gonna be useful. If everything you send over the network, people can access it easily, what kind of network is this? It's useless. So fault tolerance, let's explain fault tolerance. What's fault tolerance? Fault tolerance means the ability to continue working despite failures. Yes, if there is a failure, a link cuts or something, the network automatically reconfigure itself and readjust and continue the communication. Ensure no loss of service. This is the availability. So imagine there is a denial of service attack or a jammer jamming your network or jamming your wireless link. Can you adjust and adapt quickly and reconfigure your network so that you avoid this denial of service or this jamming attack? So this is the meaning of fault of tolerance. The second factor is scalability. So what's the meaning of scalable network? Scalable network, it can grow you can grow the network based on your needs. Let's say you have a network serving, you have an access point here in the room. This access point can provide you with a data rate of 300 megabit per second. Now, this access point provides 300 megabit per second. If only one user connects to it, he gets the whole 300 megabit per second. But if two users comes into this network and they want, then each user will get half of the data rate. Let's say 10 users came. Each user will get 30. 300 divided by 10, 30 megabits. Now let's assume these users use video streaming. Then 30 megabit per second is not enough for them. They will start complaining, saying the quality of service is bad, we are not getting very good internet connection, the video call keeps getting cut. Make a solution for us. So as an engineer, you come and say, okay, your network is congested, your network is overloaded, and you need to find a solution. The solution is to scale it. How to scale it? You say that you have high number of users, and to scale it, you need to bring either another access point that can help this access point, or replace this access point with a better access point that can provide 1 gigabit per second capacity for these users. So this is, you face it in your home. When your relatives come to your home, for example, your internet, usually when you are alone at home, the internet connection is very good. You browse, you work, multitasking, everything working smoothly, nicely, without any problems. But let's say 10 of your relatives come to your home or your friends, then you need to share this network, share the resources with your relatives. Then when you start sharing, each one will reduce the capacity of the network, will reduce the speed of the internet with respect to your device. So scalability, take it from this perspective, how to scale, how to grow your network. Everyone knows how to configure also a Wi-Fi access point or wireless or the modem that you buy from telecommunication networks. Like if you go to Turk Telecom and tell them I need internet access at my home, they provide you with what? With a modem for free. This modem contains router in it and access point that transmit to your phone wirelessly. Now, they come and configure this for you. As a computer engineer who's taking this course, you need to be able to configure this by yourself without their need. You need to, each one of you, we have a lesson, when we reach to that lesson, each one of you will go back at home and access his access point using an IP and enter to the setting and see all the settings, explain them, understand them, and be able to reconfigure them without asking the technician from telecom companies to come to your home and does it for you in your behalf. So as a you have, this is very basic thing. This is like, it should be like super easy for you, piece of cake. To understand the things, the settings, what they mean, how to connect with them, what to do with them, and how to improve your coverage, for example, how to reduce the interference. What's the interference? Interference when more than one user are talking on the same channel, causing interference. Sometimes you think, why the internet connection is so bad like this? Because of interference. If you go to the setting of the modem at your home and just readjust your channels, reallocate them to different channels that have less interference than the existing ones, then you will be improving your data rate and your speed of the internet will boom, like becomes really much better than the previous case. So the second point is have good performance after growth. If you need to scale, but also when you bring another access point, you need to make sure that it doesn't interfere with the existing one and then you kill your network. So they coexist seamlessly, nicely, peacefully with each other, and they support each other, not interfere with each other. If they interfere, the quality of service will dramatically decrease and users will start complaining. So quality of service. What's the meaning of quality of service? The ability to, one, set priorities. Example, give me example. Set priorities for what? Let's say one is sending an email. We are 3 users connected to an access point. One is sending an email, one is making a call, and one is uploading a file. Which one has the highest priority? Which one you give him the highest priority to connect to the access point and to the network? The one who's making a voice call. Because any drop or any lag in the communication, you don't understand what he's saying, yes? It's very critical, very sensitive service. Especially it's sensitive to delay. While for a one who's sending an email, I can delay him a little bit. Instead of sending the email in 1 millisecond, let this email take 2 milliseconds. It will reach at the end. So this is what I mean by prioritizing. Set priorities based on the service you are using. So I cannot say that this user, Ozan over there, who's using his phone inside the lecture, is always capable of connecting to the network and given high priority regardless of the service he's using. I cannot make such a rule. It's not a good rule. It will mess up with my network. I can say that Ozan will get the highest priority if and only if Ozan is making a phone call with his boss, let's say. This is an example. If Ozan is playing games or let's say watching videos or uploading files or sending or browsing or emailing, I'm gonna give priority for Hamza over him because Hamza might be doing something else that's much more important and more sensitive to delay, latency, reliability than Ozan's apps. That's the point. So manage data traffic to reduce data loss, delay. You need to manage data traffic to reduce data loss and delay. You want to reach Google server, yes? You have many paths around the way. Thousands of different ways of reaching there. You hear the proverb that says always goes to Roma. So always on the internet goes to, always can go to the server, the YouTube server. But which one is the fastest? Which one is the shortest? Which one gives me the smallest delay? This is question mark. This is, as a computer engineer, this is how you program the router. This is, by the way, this course is a prerequisite for a certificate called CCNA. Many of you heard of it, CCNA, Cisco Certified Network Engineer. So for that certificate, to get it, you need to have some basic fundamental knowledge in networking, which this course provides you with that. So if you want to go into that domain, you need to go into this certification after your graduation. So it's 4-level like, but like now we are providing you with basic concepts and we are not going too much deep into the details so that you just keep synchronized and keep motivated towards the subject and we don't lose you because this is very, very big subject, comprehensive, and you cannot learn it just in 1 semester. And many things are interconnected with each other. But this course is gonna, like, by going over these things, you are gonna get what you need to get started in that field. If you are interested to complete for CCNA, you can go and search for it after this class and know a little bit more. Now, what's the 4th requirement for a network to consider it good? The security. Security is an emerging trend nowadays. Every once in a while, you hear someone breaking into a network, breaking into the site of a company, telling them, if you don't give me $1 million, I will not give you access, I will get your data, you know, these kind of behaviors by attackers. So that's why security is very critical, very important. I remember one time I built a website and did everything, and I launched the website. All of a sudden, in a few minutes, there is a denial of service attack on the website. What the hell? What are they doing, man? I didn't do anything for them. I just launched. Nowadays, any website you launch, if it's not properly secure, you are gonna get hit with denial of service attack. You don't know the IPs and this and that. So what's the solution? To educate yourself about security, how to defend against these attacks. So what I did, I just went there, asked, learned how to secure this, how to do this, how to prevent denial of service, and then you get some codes, you implement them inside website, and then if there is a denial of service, it shuts these IPs that generate the traffic on your website, which are fake IPs. So this is also related to networking, how to secure your network. So if we want to summarize security, network security, then we have these two things. The ability to prevent the three things and the ability to provide five things. What are the ability to prevent? What you want to prevent? You want to prevent first unauthorized access. Bad hacker doing denial of service on your website, on your computer, in your device. You need to prevent it. Unauthorized access. Someone who doesn't have an account. You don't know him or her. You shouldn't allow them to access your service or your network or node, whatever. Second, misuse. You want to make sure that also, even the users who are authorized to use your service or get into your network, they don't misuse your network. They don't act like hackers or attackers inside your network. And third, forgery, like modifying things, playing with the data, replay attack, if you know replay attack, and this and that. This confuses the network and make it congested and shut off the service. So these are things that you want to prevent in your network. Each one of these services has a technique, we can give 10 lectures about each one of these, how to prevent it. Here we are giving you a glimpse of an eye. The ability to provide security, ability to prevent, ability to provide. We discussed what to prevent, now let's discuss what to provide. The ability to provide what? Confidentiality. What's confidentiality? You want to send your message over the network. You don't want anybody to know what's inside this message, what's written in that message. Yes, let's say we all together connected to the same network. Now I can bring like Wi-Fi dongle and connect it with my laptop and see the traffic coming from your devices to the access point and each one what he's doing. You can do this. We are here in the class. We are all connected to the same access point with some tools, networking tool. You can get the information of each one of you here connected with the network. That's why it's very, so if you type a password or anything, anybody can get it. Knowledgeable person can get it. You have to be able to do this as well, you all. So that's why you are not recommended if you are in a cafe. Don't type password, don't use, usually it's not recommended to use public Wi-Fi's, public access points. If there is someone who's smart and who's interested in getting and hacking your Facebook account or Instagram or whatever, and you just access it from there, and that guy there, he get your password and username. It's very sensitive, and this is super easy, super simple to do. This is, so confidentiality here, whatever you send over the network, I want to make sure that nobody can access it. It's encrypted. Yes, and there are many ways of encryption, many ways of protecting the confidentiality of your network. For example, current networks use public symmetric encryption and asymmetric encryption. For symmetric encryption, you have two keys, one key at the transmitter, one key at the receiver, and each node is using this key to encrypt and decrypt the data that I transmit between the transmitter and receiver. But if the key length is low, like let's say the key length is very short and it's about just 50 character or something like this, and the hacker has very powerful computer, he can guess your key within a few minutes and then get all the messages. being communicated between two nodes. This is a security threat. So researchers nowadays are trying to build algorithms, security algorithms that are resilient against such cases. You heard of quantum computers. There is quantum security, quantum cryptography. There is physical layer security, how to secure your data at the physical layer, not at the bit, at the application layer, at the physical layer. After your data gets converted to signals, you secure it there. So how do you secure it at the signal level? If you want to prevent anybody from accessing your data that's carried over the signal, what do you do with the signal? You suppress the signal. You make sure that the signal to noise ratio, the power of this signal, is below certain threshold that any device can detect and get the data from it. So this is confidentiality, preventing anybody from accessing the data that you send over the network using encryption or physical layer security, quantum cryptography, or which include asymmetric cryptography, symmetric cryptography, public key, private key, or symmetric keys, or all these techniques. You know, security is a field by itself. There is no major here that teaches security. It's just a master degree. We have some students, we are giving them security courses, especially wireless security course, and teaching them and the cryptography and this, but like, it's a very big field. Even a master is not enough for it. The second thing that you need to provide, authenticity. What's authenticity? I need to authenticate. I have a network, I have an access point, and you connect with it. And you say, I am Ahmed. I need to verify that you are Ahmed. You may be claiming somebody else's identity, and you are wanting me to give you access to the network, thinking that you are that person who's authorized. How do you prevent this? This is authenticity. This is authentication. Why authentication is important? You get, let's say, you get a hacker can come here and quickly build and deploy an access point, fake access point. And let all of you guys, all of you, think that this is the legitimate access point. And all of you get connected to this and give you your username and password and everything. He gets all username and password from you. And you are thinking that this is the legitimate access point. And why he will force you to connect? Because he will deploy the access point in such a way that is closer to you. And the signal, if the access point is closer to you, the signal will be stronger than the other access point, which is far from you. All of you automatically will get connected to it, and then disaster happens. How to prevent this? Authentication. So you need proper mechanism. This happens not only to an access point. Any two nodes communicate with each other. You need to authenticate them. So the third property that you need to provide, integrity. What's integrity? You need to make sure that the data packet that I sent over the network, nobody has messed up with it, has changed any bit in it. If anyone changes anything in it, I need to know, I need to detect, I need to know. So integrity, this is the meaning. I assume many of you are taking notes because I will be asking about this in the exams, yes? I cannot write everything in the slides here because you will get distracted and you will not enjoy the presentation. So I just put the points here and I explain them verbally so you can take notes. Integrity, what's the meaning of integrity? I send the packet over the network. Yes, send the packet over the network. And somebody changes few bits. How would I know that he changes these bits? I employ and use a method that can detect if there is any change over the medium between the transmitter and receiver using hashing or cyclic redundancy check. These are the techniques. Availability. What's availability? I want to make sure that my network, my wireless access point, my wireless coverage is always available to all the users and they can access my service at any time they want. How to provide this? What if somebody comes and jam your signal? What's jamming? Jamming is someone who comes up and establish an access point that transmits exactly at the same frequency of your access point. with stronger power. The power of this jammer will be stronger than your access point. Then your access point will not be heard by your devices. There is no service in this case. This is, we call it the network. We call the network now. The network is out of service. Please try again later because of jamming attack or denial of service attack. If let's say 1,000 hackers quickly access your website and write a code that keeps logging into your website, and your website RAM and memory and hard disk of your website is limited to 1 giga, let's say, and the requests, your website can handle 100 requests at a time, and the denial of service attacker sends 1,000 requests. What will happen? What will happen? 1,000 requests. All of a sudden, what will happen?
It will stop working.
Exactly, it will crash. The website will stop. Many attackers are doing this for new websites. Many attackers are doing this, and this is really, you sometimes launch a website, you are not aware of security requirements, and all of a sudden your website is down. So you need to learn a little bit of security and know how to implement this practically using codes. Privacy. Now privacy. The fifth point is privacy. What's privacy? In privacy, if I'm browsing over the internet, I don't want anybody to be tracking me and knowing who I am and what I'm doing exactly. Now privacy, we don't have any privacy over the internet. Anybody has any privacy over the internet? Because Google and Facebook knows exactly what you are doing. Your profile. When did you start using the internet? 10 years ago? 15 years ago? From the time you started using the internet, Google knows each and every single website you accessed, at which time, what you did, what you do, and Facebook knows the same about you. And all of them, they are storing a profile about you. Each time do you know why companies fight with each other about letting you use their browser? To get this data about you. Once they get this data about you, they know you more than your parents. They know what you like, what you dislike, what you browse, what you search for, what you access, everything. So that's why they display ads which are relevant to your likes, to your desires, to what you are looking for, to what you are searching for. Yes, some of you might be shocked. More surprisingly, just put your phones and talk about pizza, for example. Talk about that you want to eat now, or you want to buy a table, or buy some dresses, or go for shopping. Just to speak in front of your phone. And go to Instagram or Facebook, and you start seeing ads coming about the thing you just talked about. Anybody has experienced this before? Raise your hand. Most of you experienced this. Myself experienced this. My relatives experience this. You talk about something and you open your phone, it comes, it pops up. What's this? They are accessing your mic. This company is accessing your mic, activating your mic without letting you know, and recording your voice and understanding what you need. And accordingly, they display ads for you. Wow, this is really new. Nobody knew about this. You guys, you are not aware of this. You have, your phone is the biggest spy on you. The biggest spy on you. Recently, Apple detected that when Facebook opens, Facebook automatically activates the camera and start recording your face. And the camera is not active, it's not, you look at it, it's not showing any light or anything that indicates that it's operating and working, but it's basically detecting and working. Now, this phone, let this phone be carried by your son or like your little brother or anybody, or a child, let's say a child, and again return this phone to someone who's adult and to someone who's really old, and see the changes in the ads. Imagine, they know from the camera that the one who's now holding the phone is this person. Okay, the person now changed the things, changed the display. It's crazy. It's crazy. We have no privacy. Our single most important right on the internet is to have a privacy. We don't have privacy. You know, the other day they made an interview with Zuckerberg, the founder of Facebook, and while they were doing the interview, they showed his laptop. So what he was doing on his laptop, he was putting, like what I'm doing here, I'm putting a sticker on my camera and putting a sticker on his mic here. Imagine the founder of Facebook is not trusting the internet and not trusting the Facebook itself. Why? Why he's doing this? Because this camera can be activated at any time by any app or website without letting you know. The mic can be activated at any time, any website without letting you know. This is a call for action, guys. This is a call for action. Be careful. Teach your friends, your relatives, the people you care about. This, your phone and your mobile and your PC, you need to be careful with the camera. Most of my laptops and devices putting a sticker on the mic, and the mic, I cannot put sticker on the mic because I'm recording now the lecture and I want to be heard and right. But put something on your camera if you are not using it. Yes, if you go to team and you want to be seen, of course, take it, and of course. But if you are putting this laptop in your room, yes, and you are keeping it open like this, why? What kind of privacy? What kind of right they have to open my camera without letting them know, without giving them any access, and spy on us? You guys, computer engineers, yes, electrical engineers, you should be aware of these things. You should be aware of these things and take action, take responsibility. Your mic and this, they open. I told you, how would they know what you are interested in when you just talk about it? It just comes in front of you when you open Instagram. It means that they were knowing what, they were listening to what you were talking about. Isn't it? So unfortunately, we are as poor people, we don't have privacy. They are hacking us. Who are they? The best companies that we are dependent on them daily. We cannot live without them. Can you live without Google and Facebook? Instagram and this? That's the thing. That's the thing. And even you agree on all of these things when you download their app. You say, okay. When they tell you we have access to your camera, to your contacts, to your mic, you say, okay, I want the app. Get what you want. I don't care. Yes, most of the people say this. I don't care about privacy. I don't care about this. But they don't know what they are getting themselves into. So this is a friend, but also an enemy. If you want to ever be secure, you should throw this. This is the first thing you should get rid of. Okay? And if you ever want to be secure as nation, as country, you should build your own devices, your own network, your own data centers, your own everything. Your own app. Don't use WhatsApp, use your own app. So that's very critical and very important. So I think that's enough for this first part. We can stop here and continue after a few minutes. So thank you everyone for sticking around. Take care.